Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at an electron's address. So this ChemQuest, this video, will help you be able to predict the location of an electron. So we start with some information on energy levels and sublevels. So remember, guys, we learned in the previous ChemQuest, energy levels are our orbits that go around the nucleus. What we need to know, guys, about sublevels is sublevels are located inside energy levels, just like subdivisions are located inside cities. So we can use a city for an example. For instance, Boston, the closest city. So we know that Boston is the city, and it is broken down into different subdivisions or different sections. So if we want to think of some of the different sections that exist in Boston, we have places like Beacon Hill, the North End or Little Italy, Boston Harbor, Fenway or the Kenmore Station. So all of these different places, they help us paint a picture. So once you say something like Beacon Hill, if you've been to Beacon Hill, you can picture it. It starts letting you know where that place is, which section of Boston you're in. Atoms are the same way, except instead of calling them cities and subdivisions, we have energy levels, which are our orbits, and then those are broken down into sublevels, just like our subdivisions. So table one just lists a bunch of energy levels and the sublevels that exist in those energy levels. This is something that you are going to have to know. It will not be provided to you. And we can use this table to answer questions 1 through 5. So it's just looking at the table and using the information that it gives us. So stuff like question 1, how many sublevels exist in the first energy level? So we would look there and we'd see there's only an S. So it's 1. The questions are similar to that, so use the information in the table to help you answer questions 1 through 5. So we have the next page. So the next page, now we're going to learn about orbitals. So orbitals, they're like streets. They are located inside the different subdivisions where we can find electrons. So Table 2 shows us that each sublevel contains a certain number of orbitals. Again, this is a really important table. It's something that won't be provided to you, but you'll probably learn this information just from using it throughout class. So again, we just see the different sublevels and the amount of orbitals that exist in each one. In an S sublevel there's 1, in a P sublevel there's 3, in a D there's 5, and in an FS 7. So next, I have another star already written on the page. So this is extremely important, and I cannot stress this enough. This is something you need to know, and what you need to know is only 2 electrons can fit in each orbital. So it doesn't matter which kind of sublevel you have. You can have an S sublevel, a D sublevel, a P sublevel, but once you throw that word orbital on there, it does not matter which sublevel you are from. You are containing 2 electrons only. If you have the word orbital, you know it has to do with 2 electrons. So what we can look at is the second paragraph. So this is how we can calculate how many electrons exist in a certain sublevel. We'll do more calculations like this later, but for this instance, we can figure out how many electrons are in a D sublevel. So this paragraph is explaining how to calculate it. So in a D sublevel, we know that we have 5 orbitals, and we know each orbital can contain 2 electrons. So we multiply 5 times 2, that gives us 10. So pay attention between the difference between sublevel and orbital. Questions 6 through 11 are testing this difference, whether or not you're paying attention to the difference between sublevel and orbital. So you can use a few tables to help you with 6 through 10. Table 1 has all of the information you need on sublevels on the front. Table 2, right up top right here, contains all of the information you need on orbitals. And then lastly, we need to remember that there's 2 electrons per orbital. So that information will help you get through 6 through 10. Next, question 11. So question 11 right here. In your own words, what is the difference between a sublevel and an orbital? So we can use our analogy to help us. So we can use our city analogy. So remember, inside of a city, you have different subdivisions or different sections. Those sections then have streets, which help us locate where we want to go. Same thing with atoms. So we have our energy levels. Inside our energy levels, our different sections are called sublevels. Then our sublevels contain orbitals. Remember, our orbitals, that's where we can find electrons. So how are sublevels and orbitals different? To help you think about this, use our analogy, think about subdivisions and streets. Remember, those are what the sublevels and the orbitals represent. So next, question 12. Question 12. So now we're going to calculate how many electrons can fit in each of the energy level. So I'll help you guys do the first energy level and the second energy level. Then you can do the third and the fourth, model it similar to how I do mine. So to figure out how many electrons exist in an energy level, we would need to know what sublevels exist, and then we would need to know how many orbitals are in each of those sublevels, because remember, orbitals are where the electrons live and they contain 2 electrons. So if we're doing the first energy level, so in the first energy level, we can come look over here. In the first energy level, we have an s sublevel. So first energy, so we'll say first energy, that contains an s sublevel. That s sublevel then contains 1 orbital. Because we have 1 orbital, we can multiply by 2, because 1 times 2 equals 2 electrons. Remember, the reason why we multiply the number of orbitals by 2 is because we can only have 2 electrons per orbital. Because we can't hold more than that, we multiply by 2 to figure out the maximum that each can hold. So we can do the same thing for the second energy level. I just drew a little slash to give me a little division so you know the difference. So in the second energy level, we can start back on table 1. So on table 1, it tells us the second energy level contains S and P sublevels. So we'll say second energy, S and P. So then, remember, we got this information from table 1. Then we can use table 2 to figure out how many orbitals we have. So we have an s orbital and a p orbital. We can have both of them, so we need to add together. So we'll add 1 plus 3. So 1 plus 3. That gives us a total of 4 orbitals. So remember, this is from table 2. We then, because we know that there's only 2 electrons per orbital, we can multiply our orbitals, 4 times 2, to give us a total of 8 electrons. So what I would like you guys to do right now is solve the third energy level and the fourth energy level similarly to how I solved the first and the second. Figure out how many which sublevels exist, figure out how many orbitals exist, then multiply by 2. So next, we are moving on to the most probable location of an electron. So this is the shorthand, this is what it's all been leading up to, being able to predict where this electron is. So this is some notation for an electron. So these are called orbital diagrams. So, important facts about these orbital diagrams are found below right here. So this arrow, the one that's supposed to be there in the drawing, not the ones that I'm going to draw in, this arrow represents an electron. Next, because it's spinning upwards, it means it's spinning clockwise. So the opposite is true. If the arrow is pointing down, then that represents that it is spinning. So downward arrow means spinning counterclockwise. So remember, the opposite is true if it's a downward arrow. The next bullet tells us the 3p means that the electron is in the p sublevel and the third energy level. So that's what we see right here. This right here, that is the third energy level. And then this p, that p tells us the sublevel. Now we can move on to the second to last bullet. So each blank represents an orbital. So these represent orbitals. So you will have as many lines as you have orbitals. So that's what we see right here. If we look at trusty old table 2, we see that the p sublevel has 3 orbitals. So we have 3 lines. So the number of lines equals the number of orbitals. And then lastly, in the last bullet, so it tells us that the electron is in the first of 3 p orbitals. So if you wanted to label these, you could label them 1, 2, 3. Yeah, so next we can look at example 2. In example 2, we can label the same kind of bullets to help us out. So remember that the arrow, so we'll do our bullets on the side, so the arrow is an electron. What we need to remember this time is that the downward arrow means counting clockwise, so we have a downward arrow. That means electron spinning counterclockwise. Next, we can label our energy level and our sublevel. So remember the number. This is our energy level. The letter, this is our sublevel. Oh, I'll let it focus. That's good. So then remember each of these blanks represents, represents an orbital. Because we are in a d sublevel, we should have 5 orbitals. Because the number of lines equals the number of orbitals. So that's what we can do. We can double check. We look right here, d sublevel, we should have 5. And then, yeah, that's all of the important information on our orbital diagram. Remember, they're called orbital diagrams. So then next, we have a few questions. So question 13. So use table 2 and what I talked about up top to figure out why there are 5 lines drawn next to the D. Same thing with question 14. Use what we talked about up here to remember what the downward arrow pointing means. So question 15. Question 15 is the first one where it wants you to draw your own orbital diagram. So it tells us that we're in a 2s orbital. So we know that's our energy level and sublevel. So we can write 2s. Then what we need to remember is the number of lines equals the number of orbitals. So we can come look at our s orbital. Look, there's 1. So we'll put a 1 line. Then it tells us it's spinning clockwise. So remember, guys, a downward arrow means spinning counterclockwise. Upward arrow means spinning clockwise. So it tells us clockwise, so we have an upward arrow. And then that is our orbital diagram for an electron in a 2s orbital. So question 16. 16, write the notation for an electron in the first energy level spinning clockwise. So you guys can do this one yourself. When you're figuring out this one, remember it doesn't tell us 2s sublevel, but it does tell us enough enough information. So what we need to know is it tells us the first energy level. So what is the only sublevel that exists in the first energy level? And then that is the sublevel you'll use. Question 17, you can find 2 things that are wrong with this orbital diagram in question 17. Use the information up here to help figure out what's wrong. And then lastly, question 18. Question 18 is drawing another orbital diagram. So just like questions 15 and 16, try your best. Remember, guys, if you have any questions, please circle them and write down where you got stuck. Like always, I'll try to end these with a joke. Why did the Scarecrow win an award? Because he was outstanding in his field. I hope everyone has a wonderful day. I will see you next class. Bye.